Without further delay, I will invite Dr. Prateek Tripathi sir to begin his talk. Sir,
Thank you very much, Aditya, for such nice introduction. And thank you very much for the IEEE GRSS SBC Roorkee for giving me the opportunity to reconnect with my alma mater. So I think Aditya, there is a problem. I can't share my slides. I don't have the rights. Can you check for that?
Aditya, please give the
Oh
sharing
yeah,
permission for your
yeah.
slide.
I just got the permission. Thank you. Can you guys see my screen?
Yes, sir. Perfect. Yes, sir. Perfect.
Okay. Now I think the full screen visible.
No, sir. Full
Um,
screen is not visible. Is the slide mode is visible.
okay, wait. Yeah, now.
Yeah. Perfect.
Okay, thank you. So, um, let's start with some lunar science on a festival day. So yeah, I'm Prateek. I'm one of the alumni of IIT Roorkee. I finished my PhD in 2023. I was working in the geospatial department with Professor Rahul Devgar, and after finishing my PhD in 23, I joined University of Central Florida in 2024 as a postdoctoral scholar. So, um, yeah, just give me. So, coming to the first slide, yeah, I mostly work on the planetary remote sensing part and using different range of spectroscopy instrument in the lab or in the field to build spectral library for planetary mission. Not only this lunar-wise or the moon or Mars, for any planetary missions. And currently, I'm focusing on the lunar surface composition. It's more on the geology side, but yeah, that's all about the lunar-wise mission. Like, if you want to study any planetary body, you have to go to the lunar surface or any surface. Then I integrate the orbital data and the lab data together, and I'm also working on some of the mission science data products and solicit volcanism and hydration. So this is just a background about me. So I will just talk about in this presentation about what is lunar-wise and how are now NASA's missions actually going through. What is the schema? Then I have some memories down my PhD lane, like how I achieved them, and what are the do's and don'ts where, you should consider from my experience when you apply for a postdoc or any job. So I'm sorry, but I'm going to bore you with a lot of scientific part for initial 5 to 10 minutes. So this is actually this whole lunar WISE mission. The WISE stand for Vulcan Imaging Spectroscopy Explorer, VISE. So now NASA is not directly launching like okay, this is the mission we have to launch by the NASA. No, they are actually connecting the commercial lander, and they have the huge big uh, play in front of us, which is actually this Artemis mission. So Artemis era is nothing, just they are going to land human on the moon again after so many years. So you already know that Artemis first is already happened, and in and Artemis second they are preparing for it in next few months. So the Artemis first is just the testing of the launch vehicle, that okay, is it working fine. Then Artemis 2 is actually launching the vehicle, and it will just it will take the humans to the orbit of the Earth and take it back just to test that everything is fine. So before the last week, Artemis 3 there was a stage after Artemis 2 that was called Artemis 3, but 3 days before, the NASA have decided to introduce one more Artemis 2 to just make sure that safety is priority. So the next mission will be in 2027, which was supposed to be in 2028, and in 2027 it is going to take human on the space flight and take a roll around the moon and come back. So, and in fourth, Artemis 4 in 2028, actually, they are going to with the human the same way, but they are going to land on the moon. So just introduce one of the one more step in the Artemis area. So how they are connected to my postdoc and Lunar-VISE, I will not talk about it. So this all the lunar science happening in NASA or in US actually connected to the Artemis era, Artemis missions actually. So what actually motivates, like, I mean, there's a lot of question during my PhD also that why I'm choosing planetary science. I mean, how is it going to help in the real world? Like what scientific part you need? I mean, you need to have a competition in the field in after your PhD to secure some job or postdoc. You can't choose any field actually. So the main motives behind that, I mean, for not for me, for all the planetary researchers, that this is yeah. So this is the first one is the water ice at the pole. So water ice actually on the moon, it's very crucial for future human exploration, human base, and a lot of science because moon is normally dehydrated. There's nothing there and no atmosphere. So yeah, if we get to know how to synthesize that water, we will have a huge source of water in the future. I know it sounds like very sci-fi film fantasy, but yeah, that's the reality. And then the South Pole Aitken Basin, where Chandrayaan 3 landed actually in 2023, it's very, very old and it's a deepest impact structure on the moon. So it can give a lot of about the history of the moon and the earth actually. And coming to the third point, which is actually my science objective, that silicic volcanism. So there was volcanism on the moon. You can see all the black spots when you see at the moon. These are the lava. These were the lava which converted to the mare, M-A-R-E. And the white part are the highlands. So mare and highlands. Moon has two things only, mare and highlands. So somewhere there is a volcanism which is silica rich, which is not very usual on the earth. So Lunar-VISE actually targets those areas where there is a silicic volcanic happened before. And if we land a lander there, just like Chandrayaan 3 did, we will get to know about a lot of the geology of the moon and the volcanism happening on the earth. We can implicate. So, and there is no water there actually. They are very dehydrated. Those areas are dehydrated. So there are a lot of silicic volcanism areas on the moon, but Lunar-VISE particularly targeting Gruithuisen domes. I mean, the name is very complicated. I took like 6 months to learn that name, but yeah, it's called Gruithuisen domes. So right now, what missions actually contributing to the science behind the mission? So when you plan a mission, there is a lot of things actually big in background. Okay, we have to form the teams. We have to need mission planning teams, science time planning teams, mechanical planning teams, communication planning teams. So I'm in the science team, which is like core of the all teams, and we give input to different teams and um, carry out the mission. So these are the actual missions which are with the science data from these mission actually incorporating to the Lunar-VISE. So Chandrayaan 1, which was in 2008, which actually discovered water. So when I say water, it's not like H2O, it's in OH form or different forms actually, dry ice form, water ice form. Then Chandrayaan 2, which is still active, NASA LRO, which was launched after Chandrayaan 1, is still active, which is one of the most important mission for any lunar science. And then Lunar-VISE coming up and Artemis 3. There is a JAXA mission SLIM, which landed there, and it has a shadow cam on it. I think in the orbiter is perfectly fine. So with the Chandrayaan 2, I mean, most of you guys didn't know that India is the latest country or the only country which has the highest resolution data available for the moon. So NASA LRO gives 50 centimeter, Chandrayaan 2 gives 25 centimeter of the data. So how I'm connecting the Lunar-VISE to the Chandrayaan 1 and Chandrayaan 2. So Chandrayaan 1 first did the first detection of water, OH molecules in lunar poles, and it checked. Chandrayaan 1 was the actual mission which actually mapped the global lunar mineralogy. So these are the three minerals which are available, which were found there, and they also found the high silica terrains. When I say terrain, there are some areas on the moon which has a lot of silica, which is not usual on the moon actually. That's why Lunar-VISE mission targeting that. And the mission operated for 312 days, which exceeded the mission objectives. And actually, it laid the foundation for Chandrayaan 2 science targeting. Now, what Chandrayaan 2 is doing, they have IIRS, which I'm extensively using. It's called Imaging Infrared Spectrometer. It is a hyperspectral instrument, just like for the Earth. But this is the only instrument on the moon which gives the data up to 5 micron. And there's a class instrument which gives some elemental analysis and X-ray fluorescence, and it has a, as I told in the previous slides, and then 2 has the highest resolution data on the Earth. It's called OHRC, optical high resolution camera, and it can help us in identifying future landing candidate sites. So this is how Chandrayaan 1 and Chandrayaan 2 actually contributing to the Lunar-VISE and um, uh, like Artemis era, and how these missions are making a benchmark in these in the Artemis era. So now coming to more science. This is the mission actually. So this is the location. It's called Gruithuisen Domes. So it is located in a huge big area called Procedurian Creep Terrain. So I mean, you don't have to go on the name. These are named only after they found potassium and rare earth minerals and phosphorus, actually rare elements, actually phosphorus on that area. That's why they called it creep. So what mission is going to do? It's a 10-day surface investigation, rover plus lander, and it's going to do some. It has some these four instrument on that payload actually. So it is going to use some context and descent cameras before the landing so that we can get the exact location where the landing is happening. So Chandrayaan 2, 3 did a different thing where they did all the AI thing. They have different cameras. Lunar-VISE has different cameras. Sorry. And then you can see there is a VNIR's multispectral camera to map the composition and morphology at 0.2 centimeter resolution. So, and they have some IR imaging system like thermal infrared multispectral. So all the silica features on Earth or on Moon or any planetary bodies, if you're using a spectrometer, you can see only in the thermal infrared range after 4 micrometer, 5 micrometer, like TIR thermal infrared. So that's why we have a IR imaging system called TIR multispectral camera. So, and the last one is the gamma ray and neutron spectrometer. It will give the major elemental abundance. I mean, it is not dependent on the different type of cameras. It can give you a lot of elemental abundance on the domes, which is very crucial because we don't know how those silica happen there. So, oh, before moving forward, like, so this is not the NASA usual mission actually. So under Artemis, NASA uses a commercial delivery model. So they are now moving to the commercial side. They are not doing everything by themselves. Clips, uh, so they initiated a Clips thing, like a Clips scheme under which they will purchase the lander or rover, and though from which company they purchase, they will provide the science payload. So PRISM is called NASA Payloads and Research Investigation. I mean, they just named a scheme PRISM under the Clips actually, and they selected the Gruithuisen dome. So Lunar-VISE, it's one of the mission on a bunch of mission actually. So there are other, like there is a Hemdal. I mean, if you watch Marvel's Avengers movie, so there is a character Hemdal. So there is another mission called Hemdal actually. So that's how NASA is working now. It's not directly going through Artemis, going through the Clips, and Clips to Firefly glucose. So if you're following the moon landing last 1 or 2 years, Intuitive Machines, they crash landed there, but Firefly, they have a blue ghost rover and lander which landed successfully. So Firefly is going to land the Lunar-VISE in 2028. So that's how the science and coordination and the commercial uh, like commercial um, coordination happen. So NASA science team provide a science part, and coordination happen on the scale of mass and volume, data rate echolocation, thermal survival modeling, surface hazard analysis, whether there are rocks on the moon, where they are going to land, and how Firefly will help. So they will. So Firefly now. So we are in the final phase of the mission. So Firefly is giving us instruction every other day. We have to change a lot of things every other day because they are the one which are actually landing there. So we have to modify our science finding as per them. So as I talked about that, this is a investigation of moon silicic volcanism on the moon, and so this is the whole timeline for the mission actually. So June 2022 will be mission selection, and landing site selection was already done in 2023. And then there's some design review and land and rover selection happened last year only, and instruments are going to deliver this year, and it's going to launch in 2028 and going to land in summer 2028. Here, this is the moon, and somewhere here are the domes. And I mean, you can it's on the near side, which we see actually usually. So about the growth horizon domes, how they decided, how we managed to map the landing sites. So here comes the total remote sensing GIS part. Forget about the moon. So we have the dam, and we generated the slopes. This is the so this is the moon, and this is the area where we are going to land. And domes looks like this. You can see domes. I'm saying domes, not domes. So this is gamma dome. This is delta dome. So we are going to land somewhere here in a small patch. So this is, see, this is the gamma dome, and we are going to land somewhere here near the Marietta crater. There's a small crater, Marietta crater, and this Marietta crater was a suggestion by me to the Lunar-VISE science team, and it is named after a like a late geoscientist, a woman geoscientist who actually worked on the geology of the moon. And you can see on the right side, so this is the rough areas in blue, and this is the line of sight, like if lander is going to land here, that how far they can see. And this is a traverse, that okay, when lander is land here, and rover will move in this area around the crater. So you can see here there's a lot of boulders, like small rocks. So we intentionally chose that part because we wanted to know what's happening with those boulders. I know it's very risky that we might crash land, or where our instrument can struck to the boulder, but that's how science works. So Lunar-VISE investigation had two main goals. Science goal, it's like map local variation in the composition, correlate to rock and regolith properties, surface feature, and dome morphology. So basically getting to know about um, the composition. Second part, provide context for orbital measurements of composition thermophysical properties. So all we know about these domes, it's through the Chandrayaan 1 or NASA's missions. But now we have, once we have the field data from the moon, from this instrument, we can relate how close we were till the starting of the remote sensing. So there are some exploration goal. I'm not going to talk about them a lot, but they, like, one is to characterize spatial variation in lunar regolith properties of the growth horizon domes, and like you can check the spatial variations when we land there. So now coming to my work on the mission. So I'm using mission data, how I'm contributing to the Lunar-VISE, like Chandrayaan 1 and 2. I'm doing the radiometric correction or thermal correction on that, and applying some lab spectroscopy in the VNR range or thermal range, and integrating with the orbital data sets from Chandrayaan, and then science products. So for like I'm generating some hydration feature maps. So domes are not hydrated, like there are no OH feature in the spectra around 3 micron, but there are other locations on the moon. I'm also looking at the spectra, whether it's consistent with the Chandrayaan one, and developing the science data products and orbital and lab spectral validation data sets. So my research currently revolves around the lab spectroscopy. So that doesn't mean that I'm only doing the orbital part. I'm also covering. So we recently, I will talk about it. So yeah, this is one of my work here where I come. So like before me, there was a student Nick and Kelsey was here. She's now moved to Purdue University. So they actually made synthetic glasses in the lab. So what I mean by the glasses, so when um, Apollo 17 team landed on the moon near the Shorty crater, when they found some glasses there in the soil, lunar soil. So how those glasses are the result of volcanism actually when they did the analysis in the moon. So so we took the composition of those glasses in our criteria and we made some synthetic glasses in the lab to replicate what they found on the Apollo missions. So you can see on the right side, these are the lunar volcanic glass beads. These are our glasses. So they found the orange glass when they land on the moon. So we were like, oh wow, this is something new. And they also found the green glass somewhere. So synthetic glasses serve as control reference point for spectroscopy analysis of lunar volcanic material. So the glass is coming after the freezing or melting of the volcanic lava. So synthetic glasses in the lab, we can replicate all the lab analysis on synthetic glasses and we can replicate all those things or implicate to the moon mission. Okay, that may have happened there for the Lunar-VISE. So that's the thing I'm doing in the lab. And when I compared the glass spectra with, so you can see this is the moon mineralogical mapper hyperspectral image. This is the Shorty crater. This is the part where actually they found the Apollo 17 was here and they found orange glass here. So this is the pixel. The pixel is like 140-meter pixel for the hyperspectrum spectrum. This is the data from Chandrayaan 1. So we match the spectra with our lab spectra with the moon mineralogical mapper from Chandrayaan 1. We found the similarity. So that means our theory of taking analog glasses in the lab, implicating result to the moon working. And this is another work of mine I presented recently at AGU like few months ago. So you can see so I did a thermal correction on the data, which is a huge part, which is a big part of my postdoc. Like so what I mean by thermal correction, that after 2.5 micron or around 3 micron, as you move to the longer wavelength range, there's an emission from the surface, either on the earth or on the moon. So if you're getting any spectra, you have to remove that thermal part. We call that thermal part from the spectra after 2.5. So I used a Planck body radiation equation radiation and sorry, radiation equation, and I ran the thermal correction part, and I got this spectra. So I'm sorry for the font. This is my whole poster. So these are the domes, the delta and gamma domes. So you can see the red rectangle. This is the IRS data, just Chandrayaan 2 data. So, and this map is the hydration map, how much water is there. So on the domes, on this dome, actually, there's very, very less hydration. And this is from the moon mineralogical mapper, Chandrayaan 1 data. You can see on the domes, the value is still low. The higher values are the orange and red ones. Lower are the blue ones or green ones. This is a water content map from one of the my co-author Shuaili. They are one of the big shot in the planetary science field. So, and this is the spectra from IRS. So you can see at around 3 micron, we got high absorption feature, which shows that on domes, the blue one, there is no hydration, but these are other areas on the moon where hydration is too much. So this is one of the part of my research at in the Lunar-VISE science team where I'm looking for the hydration. So the result from this will actually directly help with the GRNS payload on the Lunar-VISE, which I showed earlier. So coming to my, this is the last science slide in my talk. So this is the Lunar-VISE team actually. So you can see Carrie Donaldson Henna, they are my boss actually, they are the PI, and Adri Dove, they are the co-PI of my team. And all these people are the big shot people. I am currently the postdoctoral researcher and there are some grad students also there. And you can see this person, Jessica Sunshine. So they are the big shot, which I already always wanted to work with them because they worked on the Chandrayaan 1 moon mineralogical data. Brad Denevy, they are actually Artemis 3 geological science team lead. And they all are working on other science missions and this mission also. And I'm really very empowered and privileged to work with these people during my first ever postdoc like working with the top shot of the planetary science field actually. So, and the best thing is that when I present the Chandrayaan 2 data sets to them, so it's like new thing for them, and I'm leading a work with them as a co-author. So it's like a dream come true situation for me. And yeah, and we have the partners: UCF, Arizona State University, APL, University of Oxford, Planetary Science Institute, University of Maryland. And you can see the BAE system is actually the industrial part from the NASA who actually give everything for the mission. So that's my science. Now I will talk about how like what actually shaped my during my PhD that I got this position, and what mistake I did, which I will suggest you guys not to repeat. And I will go down the memory lane that what I achieved that during the PhD, which actually helped me to get the position. Yeah. And so, um, yeah, so I'll just go quickly year by year. So, like, when I came to IIT, I mean, I finished my master's on 28th of the month, and I joined PhD on the 30th. I was in the Dehradun in Indian Institute of Remote Sensing, and it was very quick actually. So I didn't get time to decompress after my master's thesis defense actually. So my coursework actually extended for a year because of some mistake or some noob things I have done. But yeah, but it helped me a lot to think critically about my my strategy for the PhD. So, um, but I didn't waited for to attend the conference. But for like, okay, let me finish some work. Let me take like few months to finish some work, then I will think of the conference. No, my ideology was just go for the best one, like whatever work you have. So conference doesn't mean to like spend a lot of work in there. But yeah, I know there's your boss who will actually allow you to give the talk. But yeah, you don't have to present a solid work. Oh, I have the output. You can present any intermediate work. So yeah, so I attended a lot of conferences, but and so actually I started applying for the postdoc very late. Like, so I had around more than 20 conferences, which actually I attended during my PhD, and I made real contacts even through virtual events. And through those contacts, I came to know about a lot of things happening in the planetary science and Earth observation community. So I was aware of the openings, and they gave me the links on the Twitter, LinkedIn. So I was very active on social media also. Then in 2024, like uh, I I got the opportunity for a NASA internship in Houston, and then I went to Berlin in 2024 at DLR Planetary Spectroscopy Laboratory. So I had a lot of um, experience, which can easily and a general perspective. Okay, I can get a postdoc, but still took months to secure the postdoc. So in short, experience helps, but it's not a magic that okay, if you have something very big you will get, because there's a process to everything. And when you are going from one country to different country, so the boss there, they have also like a PhD group, so they have to, like, they don't have anything about your background except your documents, so they have to take a decision very, like, with after a lot of consideration. So yeah, from this slide I will say, don't wait for your fifth year to apply for the postdoc. Just start talking to the people by the end of third year, fourth year, because that's the best. That's how you save time, because it took like few months for me to get into that. So this is my year by year, um like so my year by year strategy for the PhD, because I knew that like how much I did, it will be insufficient if I don't spread my wings. I know it will be very risky to do that, but for my first 3 years, almost everything was virtual. Like, the COVID happened in year two. So for the first year, I actually focused on building lab skills. And I didn't waited a lot for the data. Actually, I learned the instrument by myself, thanks to my PhD supervisor, Professor Rahul Devgar, because they allowed me to do that. I mean, I will say I'm lucky. I was lucky actually, but they helped me a lot. Even my SIC chairman PK Garg sir, they also motivated me every time I met them. And because there was a project with my boss, So because of my work I was doing the first year only, I got the chance to visit East China Normal University for a month. I did the ASD spectrometer FTIR so I found a lab like chemistry lab, another lab where I actually approached my boss. Okay, they have the instrument, I want to work. So PhD, it's not a competition actually. You have to do everything by yourself. You have to do everything by yourself. You have to initiate it. I know it sounds scary. We sometimes we don't have those backgrounds. Sometimes you're working on a project in PhD which you don't know. But here comes the catch. I mean, there's no shortcut to the literature review. You have to read. You have to increase your knowledge gap actually. And I had two conference paper in my first year only. Like there's a spectroscopy meeting held in IIT Roorkee. Coming to my year two, I started attending the international events virtually. Like I know, so they were like in planetary science. So planetary science field is a small field, like subset of earth sciences and astronomy, astrophysics, and remote sensing also. So luckily, I came to know about the physical research laboratory in Ahmedabad. So they organized the first ever planetary science summer school in India, and I got selected for that. That's a different thing, that because first they put me on the wait list, then they said no, and then I booked my IPL match ticket. Then I came to know that on the same day I have to go back to the Ahmedabad, so I canceled my IPL tickets and I went to Ahmedabad and got that internship. And that internship was one of the changing point in my career actually, because I got to learn about a lot of planetary remote sensing basics there. So PRL was really, it's really a good laboratory actually to do your research. I mean, during your PhD also, I mean, if you are in, so they are also doing on the earth actually, but if you are interested in this field, you should definitely be in contact with the PRL. Just make your contacts, ask them for the internship, or maybe just go apply for different summer schools, or they have a lot of conferences there which have a virtual participation link. So and during this that time, Italian Space Agency released the hyperspectral data set after 2009, like the first ever. So it was COVID. I remember the first lockdown. So I thought that, I believe that the COVID was the bonus period for PhD scholars. So I also believe that, I also understand that not every PhD scholar had that of setup at their home to work like that. But I was lucky that I had. So I got the data in May 2020, and I published my first ever paper on Prisma, the first ever SCA index paper on the Prisma in June actually. So I did everything to process that new hyperspectral data sets. I explored everything by myself and it got published. So it gave a huge boost to my career. And I attended some ESA workshop and then ACRS and my first Indian Planetary Science Conference, where I presented data I worked on lunar source. These are some different other features. In year three, I went for almost every conference I could have gone for. See, going to the conference doesn't only mean to you have to present like virtual one. You just attend and talk to people, just take it easy and apply for as much as travel grant. I will say again that I was so lucky that I got to know about a lot of travel grants actually. Then I got my second paper in, and then I got some grant and I attended these big planetary science conference. And I started building my network, and by year four, I got the Lunar Planetary Institute and NASA Career Development Award in 2022 for my work on impact craters in India. So I actually forced Adi Gaksar to go on the field. He also suggested me to take the instrument, but and the science was his idea, and he actually motivated me for that field. So I went there with my cousin, because what it was very near, those craters were very near to my home, and it was my brother's engagement day. So I took a lot of samples, brought them to IT Roorkee, and did the spectral sample analysis by myself, and then I submitted the abstract and I got that award. So all of my hard work gave me this one of the prestigious graduate student award, which actually helped me strongly in my career. Then I started working on some of the mass data, and these are the two impact creators, which gave me three conference papers. Then in the year five, I went to the DLR spectroscopy lab. I got a funded from Europlanet Society for 15-day visit, where I generated 200 spectron, very sophisticated vacuum control instrument, And after that, the the best part of my career happened. I got a NASA internship at LPI, where I worked on the plotting a traverse for the Artemis 3 mission. When they land on the South Pole on the moon, where they will go for the science, and then where they will walk on the moon actually. So we were the 5 interns, first batch after COVID, and we generated a 500-page atlas for that. So that was our contribution to the Artemis 3 part. Then I got some other travel award. So this is like you can see by year, like my conference papers kept was consistent, or my general paper kept increasing, but my application to different networking event kept increasing. And don't be scared of it to take the risk. I mean, the best thing you will get, the worst part, you will get the rejection. And it's totally, I mean, I applied for more than 70 postdoc. I got the rejection. Then I got suddenly this one, and then after that I got 3 more, but I chose that one. So now I will just show some pictures. This is almost my end of my slide, like few more slides, only the pictures. So here comes the fun part actually. So this is, you see, this is the Germany lab where I went to do the spectral analysis. On my hand, you can see this is the Apollo 16 sample, and this is the Apollo 16 lab. And you can see, if you see on the camera, I have the Apollo 16 dust with me in my apartment here in Florida, and it is like a very prestigious for me that you have a moon sample in your apartment, which I carried everywhere with me actually. So this is the lunar sample I worked on. And now we'll talk about some achievements during my PhD. So this was my internship at NASA and Lunar Planetary Institute. We were 5 people from different stream. I was the planetary science and GIS person, and this is the Chandrayaan 2. So I was briefly a student member of Chandrayaan 2 science team. So we did a lot of meetings in Delhi and Bangalore. In Bangalore at ISSTC in 2020, just before the COVID happened, I got the chance to first ever work on the hyperspectral data from the Chandrayaan 2, and it was really great. So during my Houston visit internship, we went to the world's one of the biggest Antarctic meteorite curation facility, and you can see in the glass, this is the meteorite actually. This is a huge meteorite, and this is the lab where we worked with the meteorite samples. This is the meteorite, and these are some other meteorite, and they are telling how they actually keep take care of those samples. And this is just an image from LPI. And this is the best part. This is lunar sample laboratory facility at NASA Johnson Space Center. So these are the lunar rocks which they brought from the moon. You can see, and they are preserved like this so that they will not get exposed to the atmosphere. This is Apollo 15 rock, 16 rock, and Apollo 17 rock. These are the rocks from different lunar mission. And this is my team. And you can see the lunar rock in the background. And this is the astronaut training facility at the NASA Johnson Space Center. You can see very sophisticated machine, and they have school interns and undergrad interns working here. And yeah, and this is we outside the mission control center. If you have seen the movies, a lot of movies, when they call copy Houston, Houston, we have a problem. So they all happen here actually. And this is just a small video from my internship. So a few people from who are attending this lecture, I think they know that I went to the internship, and this video I showed like 3 years before also. But this is my contribution to the lunar sign Artemis thing. You can see this 001 and Slocan 6 are the probable landing site. All these oranges are the traverse, and these are the traverse where they actually can go and do the science to different permanently shadowed regions. So for lunar south pole, because of the lunar tilt, we have a shadowed regions. They are completely shadowed and permanently shadowed. So this was just a video to show what I did there. And like, I know planetary science field, it's narrow, but there are a lot of um, opportunity here, there, like target mission, like during academic research, just if we target on the missions linked lab, there are high probability of getting the right direction. And yeah, just my advice that publish all PhD papers even before, even after PhD. Like, don't wait for them. I'm still waiting for 2 of them, which I'm really disappointed. And apply to all of the postdoc position. Don't think about that. Yeah, I know getting the recommendation letter is very tricky, but You have to do that once you finish your PhD or coming to the end of the finish your PhD. Conferences, attend as many as you can. I know there are fund issues, other thing, but check for the virtual part. Or if it's a national conference, I will say you can go once or twice on your expenses if it's it's not that crossing your budget limit, and build international collaboration. You don't have to go somewhere, just write the email. You can wait for the email, you can send as many as email, but use the AI tool very wisely, because they can help you writing those emails. And space industry is building up rapidly even in India. I'm not very much aware about that from, because I'm not in India from last 2.5 years, but yeah, and remote sensing GIS actually connecting to the both of them. And then data and technology, you must be aware about all these GitHub and ML and RS skills. So this is one of the parts with the writing the email, which I thought I could share with you guys, because that helped me a lot on that. So it's not only about the postdoc, it's about the internship or getting in contacts. Like, so when you write an email, I will suggest, do not ask them what you want to do. Just take out their expertise, what they're working on, what project they have, and tell them what you want to do. So they will never figure out your interest. You have to state your direction clearly. I know in your PhD initial year, it's very tough to do, but you can give a vague direction. Okay, I want to work on that. Maybe I was thinking, maybe if we can work on that. Yeah. And so use AI for tone, but not the content. So like your ideas still be yours, just you have to use those very smartly. And do keep engaging on the LinkedIn and Twitter, actually, because sorry, X, because this actually helps a lot. You will get a lot of feedback and a lot of connection from that. And so for example, if you're applying for an internship or a postdoc and you don't know how the professor is, so in US, particularly in US, I don't know about the other countries, there are website who actually rate those professors. You can go there. Or the best thing is to do, if you want to know how successful is the science group, just approach the alumni from that group. And if you don't want to, just look where they are working. If they are working in the good institute, that means the research group is really good. So target best people, not countries. So you must be thinking it's very easy for me to say that because I'm in the US now. So I'm on the NASA project. So it's easy. But believe me, like, you have to target the best people, because I've seen a lot of PhD students doing here some shitty things. Like, they're just sixth year of PhD and still they don't have an idea what they're doing. So best is to get the best ideas, get the best people in the lab, actually. And so when you send an email, you can wait for the replies, but don't hold upon. Like, just don't on anchor on one person, just move ahead. I know it's very irritating that he didn't reply me, she didn't reply me, I sent them a big email. The first thing, don't send a very big email. I know it sounds very like, okay, I want to say something. I mean, I did a lot of big email things, so I never heard from them, but now I almost hear from 70% people of them. And one of the things, when somebody is writing a recommendation letter for you, just please follow up and say thanks, even if you're not selected for that thing. That's really helps a lot. I learned during with Adi Gaksa, that's it's very important. And once you finish your, so as I told you that you have to start applying by your third year and or at least in the fourth year or the year before you're thinking to submit your PhD thesis. And if things doesn't go as your way, even if you get the position, even if you don't have the time to join, if you have few months, I will suggest don't sit on in your home. Like what I did, I asked one of my undergrad my bachelor's institute to give me a chance to introduce remote science GIS to those people in my hometown, and they did. So I'm not saying that it's very easy to get a job after PhD. It just because I had contacts there, so they knew that I did a NASA US thing, so they gave me the chance. So in short, I'm saying that if you have a gap between a PhD and a postdoc, don't be stressed. I know it's a time to be stressed because you don't have any income, but try to find other things to join in that period. So these are the hard-won lessons I earned, that publish early and often, and be mission aware. So for mission in planetary science, you have to be mission aware, but in other fields, you have to be keep yourself updated on different things happening around you, the latest one. You have to connect with them. It doesn't matter how you do, and attend more conferences or event or meeting, even if happening in the PhD, like some research in the poster day or something. I know there were posters this happened when I was there, that collaborate with other people. Like just send them cold email, like because co-authorship will during a PhD will help a lot. I mean, believe me, like once they see a co-author paper in a PhD CV, they will get impressed. Doesn't matter which country you're applying. Master your tools and apply early and broadly. So these are like last three slides, like my kind of journey here in Florida. You see, I'm meeting one of the astronauts from Apollo 17 mission at the Kennedy Space Center in Cape Carnival in Florida. You can see the Atlantis behind me, and on the right side you see a bright glow. So this is actually Shubhanshu Shukla taking off for the journey. I was there at the Kennedy Space Center. It was a very proud moment to see them launching into the space. I still remember those sounds in my ears, and a lot of media people were there. And as an Indian, it was a very proud moment for me. And you can see this is a exodet lab. So we actually test the lunar rovers on the lunar simulant. This is the simulant which we made in the lab. Not we bought that. So so this is my team. So this is Benjamin, this is Abigail. She's an undergrad student and she got a lot of, now she moved to Colorado Boulder. He moved to Texas, and they are really working at a very good location. And this is the rover we tested. We heated the regolith and we checked, okay, if the rover is passing through, how much temperature they are going to retain or release. We are just trying to correlate with the thermal spectroscopy part in the Lunar-VISE. And this image is one of the images from the hurricane outside my apartment. So in Florida, you will see a lot of hurricanes. And it was the one of the deadliest hurricane I have seen in my life here. But yeah, nothing happened. Like I mean, this conjuring type environment outside. And not every day you go to the universal. And I have to introduce to my best friend here, like which helped me a lot. My cat, Leo. He's a nice guy. He's sitting right there, near my leg, and waiting for his breakfast. And this is my science group. This is my PI, and this is um a outreach committee event we did for the school students. So I did a lot of school students event thing here. We show them some sample. We give them stickers, and we give them some thermal camera you can see, and the lunar globe to do some activities. And this is the Niagara Falls. I went for the Venus analysis group meeting. I mean, you don't go to Niagara Falls every day, but thank God I got a lot of grants here. And you should connect to your culture. You can see that was the best part, that I'm living in Orlando. You don't get a lot of things like you don't get a lot of opportunity to live in Orlando. Orlando is like theme park thing. You can see Disney, and you don't go to Universal every weekend, but I'm so lucky that I go every month there. Like, okay. And but yeah, these were the small lived memories here. And yeah, so thank you very much. And I'm sorry, I think I took too much time. I think 10 minutes more. But yeah, thank you very much for listening to me. And I hope I was able to give you some insight about my journey. And now I'm open to the questions. Thank you very much.
Yes, if anyone have a question, they can put it in the chat box, or either they can unmute themselves and ask. Yes, Srikanth, you can unmute yourself.
Hello, am I audible?
Yes.
Yes, yes.
Hello, sir. I am Srikanth. I am also a research scholar in IIT Roorkee in electronics department. I am also working on this. I'm working with DFSR full data, Chandrayaan to DFSR. So my question is, what is your take on radar observation for water ice at the lunar polar region?
So Shrikant, I mean, unfortunately, radar is not my expertise. So I mean, I was looking at the mini RF data, like not the DFSR. I was looking at mini RF data a few months ago for the growth horizon domes. And honestly, it drained me because that's not my expertise. But I have seen some publication by the DFSR team, and I have seen a talk by the Shashi Kumar sir from the IRS. Um,
Yes.
and I mean, I will say the data is much better than the IRS because IRS has a lot of issues. Like they have a lot of filters there, which was not supposed to be there actually in the IRS. I don't know how they designed that instrument, but the DFSR. So here in US, people are trying to work on the DFSR data, but I'm kind of very happy that they don't have a lot of background about that, so that we can teach them. Maybe once you get the expertise on that, you can also teach them. But yeah, the dual frequency SAR data, like I think this is the first type of data like that, having a dual frequency, and for the moon with a very good resolution, if I remember, because they shown a slide during the Chandrayaan 2 data users meets in 2021 actually. So yeah, I mean, I will say the data is much better than the IRS, and I will be happy to explore in the future after I am done with my IRS part for the LunarVISE.
Okay. Okay. Another question. You just said that the Lunar-VISE mission is for only 10 days.
Yeah.
Why 10 days?
So just like Chandrayaan 3, it land. So like one lunar day is like 14 Earth day actually.
Yes.
That's how we give the name. So for Mars, we call them Sol. For lunar, we call them one lunar day. So the mission is designed just to so the time period they took in the August 2028 when LunarVISE will land there, we will have a sunlight for only 10 days. After that, it will be a blackout. So like this is initial like 10 days, but you know how the funding situation going around the world, how is the like things going around, so they might changes. And if they get, so I mean, unfortunately currently the US government, they actually slash 60% budget of the NASA right now. So which is horror, like it's a like very horrible condition for all of us here. But if they get more funding, maybe they will extend for 14 days. So you can't go for more than 14 days because there is a eclipse period there. There's no sun there. So all of your instrument will die. So that's why they decided, and all the mission planning, all the traversing, and the I showed the national traverse, which was very small. So to get the composition history for that area, this much is very more than sufficient to get the images and the GRNS data from the surface. So how they planned it actually.
Yeah. Anyways, very great experience you have. I would like to follow you and follow your path in future.
Sure. I mean, you're already working on very like I will say scary data, because I call it scary data because I mean never worked, but that's a stream which most of the people don't go towards the SAR data. So it's a good thing for you. Just don't like narrow down yourself. Try using the other data sets also, and this is data which most of the planetary science community in US or in Europe don't know about it. So present it, okay? Even if you find a small meeting, even if you have to show just one slide, just talk about it. Okay, I'm working on it. So how then that's how they will know that okay, they're working on it. Because when I joined here, they didn't know that Chandrayaan 2 has a hyperspectral instrument. I was like, yes, they have a hyperspectral instrument. So that's, I mean, there's like a shortcoming in the ISRO PR actually agency. They don't do a lot of PR thing. They have a lot of good things, but they are not doing now. Recently, they are doing, like, I know I'm following them, like they are doing a lot of internship and everything. But with the Chandrayaan 3 thing, after Chandrayaan 3 thing, people know a lot about the Chandrayaan thing here. I mean, you get a sense of proud moment that okay, yeah, oh okay, India Chandrayaan, yeah. So yeah, so just keep working hard and publish it and show it to the people that you're working on that, because there is a small mindset in the West or in the Europe part that okay, I mean, they like it's very easy to criticize the Indian products, even they are not bad, but people do that. So you have to show that what you're doing.
Okay. Anyways, thank you.
Thanks, Chika.
Any other question? Okay, so I have it. You want to speak anything?
Hello, am I audible?
Yes, yes.
Sir, how will you get the reference spectra for the moon studies? Will you extract from the imagery itself with any in-memory extraction algorithms?
Uh,
Or
so so there's a website called Z Lab. I mean, if I'm allowed to share my screen again, I can show it to you. Just give me a second. Can you see my browser?
yes, sir.
Yes, sir.
Yes, sir.
Okay. So Z Lab Brown University, if you go there, they have all the spectra from the samples the Apollo team brought back to the Earth. So if you click on spectral database, it's free to use, and this is the spectral library, and they have every, like for example, I will search for Apollo, and see, this is one of the spectra, thermal spectra, like reflectance spectra. So you will find every spectra there on the relab. So they have every sample. For example, you see 1555. This is like Apollo 15 mission, and where they found it. Like they will tell you everything where they found it, and there's have every information there. This is the ASD spectra like this. Like you can see up to 2600. So these are the reference spectra for the moon you can find on the relab. All there are a lot of published papers, and yeah, and for orbital data, we only have Chandrayaan 1 and Chandrayaan 2. I hope that answers your question.
So similarly, is there any spectral library available for Prisma, like satellite
Prisma.
spectral library?
Oh
Yeah,
yeah, I
Prisma.
mean, oh yeah, I'm sorry I didn't talk about that because yeah, I worked for on the Prisma data sets like and this is I'm currently working on the Nmap also. So I think the USGS I'm pretty sure you heard about this USGS spectral library. So even if you go into the NV, they have this spectral library there for the minerals. I mean, I'm not pretty sure that what materials you are working on, whether you will get the spectra in that library, but you can get it from here, USGS spectral library. They have the spectra for almost every earth material, and if you don't have the standard way to do that, go for the research papers, and if they have some spectra and if they provided a data in the supplementary material, just take that, or otherwise just send them an email that I want that data for my use, and I will give you the acknowledgement.
Okay,
So
sir.
yeah, this is the spectral library, and so you have the NV's access, right?
Yes, sir.
Access. So if you go into the NV and spectral library viewer, there is spectral library by JPL, USGS, and other things. So this is the same USGS library you will found there. But if they updated it, keeping updated it, so I think you will find the West data from here. I mean, if you're what materials you are working on.
Okay, sir. So I have this kind of spectral library for USGS and the ecostars, these things, but
Mhm.
they collected very long back. But if I took one image into recent, for example, 2026 imagery, can I use
Mhm.
that for this imagery?
I mean, so I'm a geology guy, so we can use the data acquired 20 years ago. But if you are working on some other features, then you have either have to go to the field, or maybe you have to contact with the people who recently went there. Like recent spectral library people are so on ResearchGate. There is a thread where actually they put very like spectral library. Um, link, maybe just give me a second. I'm just trying to find that thread. Um, I mean, I remember I found that thread on the okay. I mean, it will take a lot of time if I find this. So yeah. So what material are you targeting actually?
I'm mainly focusing on the species, sir.
Sorry.
Like tree species.
Oh, tree species. Okay, okay. I will suggest you to I mean, Okay, I will connect you with just ping me after this call. I will connect you the people who are working my batch from the IRS who are working in the forestry actually, who might have some link to the current spectral library, because I'm not working on the earth right now, but I'm pretty sure there will be something for you with them.
Okay, sir.
Yeah.
Thank you, sir.
Mhm.
Doubt regarding PhD.
Oh, okay, nice. That's great. Yeah, I mean, keep working hard.
Currently, I'm MTech student, MTech second year.
Okay.
If I want to pursue PhD, what will you suggest to go foreign or India?
Oh,
So
sorry. Can you repeat the question? There was some noise in the voice.
if I want to pursue PhD, will you
Mhm.
suggest go foreign or in India? If foreign,
Uh,
in case it is better than India, like supervisor or lab or funding.
So, see, you can get a good supervisor here, or bad supervisor there, or bad supervisor here, or good supervisor there. So, I mean, it's honestly your luck or the amount of research you did for the research group. But coming to the funding, yeah, the countries outside have better funding, but it's not the only part you will see when you come to the US or Europe, or you go to some other country. You have to target the best group actually that I mentioned earlier, because the university here, University of Central Florida, I mean, I will say it bluntly that okay, the ranking is not that much good, but the planetary science group here is really good. Like they have the PI from, I showed the image of my team actually. They have the PI from best NASA missions. So like I used to think, okay, the big people here are working in the Ivy League university, Brown, Stanford, Harvard, and if I want to get a ma- postdoc or PhD, I have to approach them. But that's not the thing. You can go to other university which are not Ivy League and choose for the good people there. And yeah, it also depends at how much salary you are getting when you are targeting the foreign one, because you have to go for the expenditure. I mean, if you ask me the Florida, I mean, it's very costly, but yeah, luckily we don't have income like one of the income tax here, so it's kind of easy as compared to the other states here. But for a PhD student, you will get a good amount, but I think in India also, like they have TA and RA duties. So here your salary totally depends on the TA and RA. So you have to keep all these things in mind if you're comparing PhD in India or in US. So I will strongly suggest that I mean if you are targeting in this field like forestry, like trees for that, I mean, if I got it right, uh just try to reach, I mean, there's good professor in the IIT Roorkee also, but if you try to reach other IITs and maybe FRI and try to see how much funding they have and how research is going there, and yeah, so funding wise, yeah, the Western countries and different countries are better, but I will strongly say again that aim for the best like group actually, because a lot of people who were with me during my PhD in different streams, they did really good. They kept their calm. They were not like me that okay, publishing, I mean conferences, they were not, they were like calm, but and they are now a very good university, University of Virginia, and somebody as Purdue University, and they I mean, so your research group really matters. Like I know things will come in your head, okay, if I'm doing in India, I might have don't have that exposure and the thing, and but that's not the whole thing, because I did all of my exposure back in India. I got that internship when I was doing in India. I got the PRL thing when I was in India. I got the Germany thing when I was in India. So it highly depends on you and the research group actually you are choosing. And considering the current geopolitical situation, I will not discourage you to apply for different countries, but 2 years ago, we were not forced to think, okay, what we will do if something happen, like some visa thing happen, something. Now we have to think about that also. But that doesn't stop you to applying for at a lot of opportunity. You should apply there. So target for the best people rather than the best university or institute.
Thank you so much, sir, for the just presentation.
Thank you.
Sir, I have one like last question.
Okay.
Like you said, identify the research group. So apart from seeing the publication and work of the research group, what are the others way we can like judge a research group?
So just I mean, what I did, my criteria was to look for the members where actually they are going to present their work, what actually, so what previous member actually are doing this when they passed out from that research group, what they are actually doing right now. If they're doing something in a very good university or that means okay, that group is giving you a very good output about the research. And here people, like in Western country, people are very pretty straightforward. If you reach somebody, okay, I want to join this person group and you have already worked with them, can you give me a broad idea how's the group environment? So they will just tell you straightforward, like if the professor is an idiot, they will just say, okay, he's like, he will just torture people. And but he's very, some people, some, okay, that's the real harsh reality, that some people are really like very stubborn and they are not good professor, but they're good, very good science. I mean, I will take example Brown University. You might not have thought about that, but Brown University people are very, I mean, I have few Indian friends there, so they just tell me the story. But they do a lot of good science actually. So I mean, you can't take guarantee of the person's nature, but I mean, all you see, you do all you want to do some good science. So just I mean, publications is not very tough criteria to identify for the good research group. Everybody can nowadays they can publish because they have grants and like journals also made it very pretty easy for that. But if you look for the people who work there and where they are working right now, and how much experimentation and other things they like, for example, if you're going for the research where you have to do a lot of experimental stuff, like research, like lab based stuff, so just take a look that whether they have access to the instrument or not. You can see everything on the website. And if you can't see, just email them, do you have that access for the web instrument? And if you're working on the theoretical part, still you need a workstation. I mean, honestly, I will say, I met a student from the um, uh, Brown University, I think, and they didn't have their system for 2 years. I mean, the reason was different because they never inquired with their boss before joining. Okay, do you have the money for the system? Because unlike India, you need to have some funds here for your student to buy them or something. Otherwise, you have to rely on your laptop. In India, it's very, very like it's like a common thing. Like in every lab, they have system. You can get the system, which is very easy. I mean, I really miss this thing here. So yeah, I mean, you have to look for the resources where the people working, and do also look at the research papers also, and how much they are involved with different other activity. For example, my boss used to work on the diviner data, like one of the temperature data from the moon. Now they are expanding their to lunar-wise and other things. So you can see, okay, they are very spreaded. So you will get more opportunity to work in that group. So that's how you can do. And this like so unfortunately in India you are not allowed to write a proposal, like be a PI. I don't know whether it's changed in last 2 years, but here as a PhD student you can be a science PI. And as a postdoc I can write my proposal. I submitted 3 proposal like in last 1.5 year for more than like $1,000 of funding. I mean, still they are still in review actually. I don't know whether it will get, but yeah, I mean, it's like a wholesome experience when you submit as a PI. Okay, I will have my student, I will have my my research lab. So, and you can also look at the factor that whether they establish their own research lab, whether they have that website, whether they have those students. For example, my boss had his lab from so many years, but they started building the website right now. So these are the factors, and as soon you will progress to find the professors or lab, you will see, okay, yeah, I can look at other factors too. I hope this helps my reply.
Yes, sir. Thank you. Now, I would like to invite Mr. Arnav, Vice Chair of IEEE Student Branch at IIT Roorkee, to deliver the final vote of thanks.
Thank you, Aditya. On behalf of IEEE GRSS SBC IIT Roorkee and your special body IIT Roorkee, I formally thank Prateek sir to join this lecture and deliver this lecture. I'm personally very happy to hear from Prateek sir after this long time. We used to have these discussions and hear from Prateek sir in the lab when he was here. So I thank Prateek sir, especially it is like 6 a.m. in US, so it is a deal. It is a deal for Prateek sir to join. So I especially thank you for that. And also I thank all the attendees who have joined for this lecture. And also I urge them to join the next lectures. There are lectures lined up also. I think the next lecture is of Dr. Harshit sir. So that the date will be, I think, will be published in a few days. So finally, I thank everybody. I thank everybody for joining this lecture. Thank you everyone.
Thanks. Arnav.
So Aditya, I think you can conclude the meeting.
Okay, and sir, I will also like